let's continue with the second talk. Please welcome Golo Roden with Node Streams.
Thanks a lot. So, welcome everybody to the second session of this evening. And my name is Golo. I'm founder and CTO of a startup called The Native Web. And we're doing product development based on JavaScript and Node.js. And if you want to support us in creating our product, you can also book us for consulting on JavaScript and Node.js. So if you have any interest in this, feel free to ask. So before we start with the session on streams, I have two questions. First, although the first one is not a real question. First, Christoph asked who knows Enter.js. And could you guys who already know Enter.js please again raise your hands? Okay, it's actually only 3, and I think we have to change this. So Enter.js is that one big new JavaScript conference that's taking place in Cologne in summer 2014. And the idea is that we have already lots of JavaScript conferences in Germany and in the world. So what is different with Enter.js? And we thought about all the crazy and interesting and funny things you learn, like flying quadricopters and programming boats and amazing WebGL stuff and things like that. And that's really, really, really great topics. Although the only little disadvantage is that this is a lot of fun, but most often has not too much to do with what we do in our daily job. And we thought, what about a JavaScript conference for enterprise JavaScript? And let's bring enterprise JavaScript development and professional JavaScript development, let's bring it together with topics like running JavaScript applications, like administration, like DevOps and all these things. And this is what we want to target with Enter.js. That is the Heise publishing company, in combination with Duplex. It's also a publisher for books, for IT books, and last but not least, the Native Web. So, and our call for papers is running. So if you are interested in giving a talk on enterprise JavaScript, or if you want to give a talk on running applications, especially JavaScript applications professionally, feel free to submit to our call for papers. So this is what Enter.js basically is about. And if you don't want to submit a talk, but you want to come as a visitor, of course you're welcome also. So, okay, enough talking about conferences and things like that. Let's go into streams deep dive. So first of all, before I start, let me ask you, who of you is already running productively on Node 0.10? Okay, so this means most of you are still on 0.8 or below, right?
Or not in production.
Okay. I can't imagine that there is any company on earth who is not running a Node in production. But, well, okay, who is running Node.js 0.10 at all, be it in production or anywhere else? And who is running Node not 0.10, 0.8 or 0.6 or something like that? Okay. So, okay, because the reason why I asked this, because some things have changed between 0.8 and 0.10, and you should know about these changes. And, well, I've prepared some small demos for you. And the first I would like to show you is a little neat web server. I called it Server Classic. And I guess it's a listing that every one of us could have written by him or herself. It's just a little server, and it does nothing but take the incoming request and combine it with the current directory folder name and, well, assume that there is a file with the name of the request path, load it, and send it back to the client. So just a simple echo server for files, if you would like to say so. And, well, when we look at this, this is the most naive approach of how we can program or how we can write a program like that. And you may ask, well, what's the problem with it? And, well, there are actually two problems with it. The first problem is, both are related to this read file function. The first problem is that read file needs to load the file before it calls its callback and before it sends this file to the browser. So, of course, if we load a file such as etc password, well, never mind. If we load a file which is 3 gigabytes in size, it's not so funny anymore, because this means that we need to load 3 gigabytes of data to the memory. And this is disadvantage number 1. So if you do it like this means that your server will take a huge amount of memory. And disadvantage number 2 is directly related to this, because this also means that it's quite slow. Because loading 3 gigabytes of data, even in times where we all have SSDs and things like that, it takes some time. And of course, now you could say, well, this disadvantage number 2 is easy to solve, let's use caching. I'm not sure if I would like to cache 3 gigabyte files in memory. Well, it's not the best scaling solution. And this is usually such a solution people come up with and then say, hey, you told me that Node is highly scalable. Somehow you're wrong. Okay. The nice thing is that we can answer, well, the implementation is wrong. There's an even better way to do it. And this is using a stream. Because all we do is load a file. And once we have this file, send it as is to the browser. So why should we wait for finish loading the last byte and then start sending it? Why not load and send at the same time? Just read 100 bytes, send 100 bytes. Read the next 100 bytes, send them, and so on. And the nice thing is that Node makes this really, really easy, because the FS module, besides read file, has another function which is called read stream. This is the function over here. And basically it also takes the file name as a parameter. The difference is that it does not use a callback, but it returns a stream synchronously. And this is basically the first thing where we enter streams on this evening. And you can imagine a stream as, well, I've once read a really nice explanation. A stream is an array, but in time. Okay, so what this means is an array of data is just, well, let's imagine a long space of data. But the idea of an array is that, whoops, it's there. And the idea of a stream is basically the same, with the only difference that it's not there at once, but there's the first part, then the next cells come, then the next, and so on. And this can go on forever. So basically, a stream is an array that is loaded over time, or calculated over time, or whatever. The time is the crucial part. So, and what this does is exactly what I described before. Load data, send. Load data, send. And it does this because the read stream simply returns the stream, and the stream is only, well, a cursor was mentioned in the talk about Meteor, and basically what it returns is a cursor to a part in a file, and then it reads some bytes from this cursor on, moves the cursor, and once it has read these bytes, it sends them. And the function that does all this magic is this small 4-letter pipe function, and we'll come to this again a few seconds later. So basically we're streaming data now, and this is great, and this is awesome, and this is easy, and everything is fine, and this is what we do use in our everyday job, but we rarely think about what goes on under the hood, and this is not such a good idea, to not think about what happens under the hood. But before we go to the deep dive, let's first have a look at what we can also do with streams. The nice thing with streams is that we here concatenate two streams, or we pipe one stream into another. We pipe the input stream, which is the file, to an output stream, which is the result stream of the HTTP server. So now you can imagine if we are able to pipe an input stream to an output stream, perhaps we are able to see that output stream again as a stream and pipe that to another stream. So we can have a chain of streams. And this is exactly what the pipe function allows us to do. And this is what the next example shows. The server gzip example, which basically is the very same. The only difference is that we take the read stream and pipe it not directly to the response stream, but first we pipe it to a gzip stream. So we get a compressed version of that file, and then again we pipe that file to the response stream. So we have file loading, file compression, and file sending all happening at the same time without the need to use huge amounts of memory. So the question is, how does this pipe method or this pipe function work internally? And for that we need to know a few things about how streams work. And as I already said, there are basically two types of streams: input streams, output streams, or as Node calls them, readable streams and writable streams. Using a readable stream is way more hard. This is why I start with a writable stream. Using a writable stream basically looks like this. First of all, you need to get a writable stream from anywhere. I'm just using a magic get writable stream function, which returns a writable stream to us. Yeah?
This is all Node 0.10 because you mentioned it?
No, this is all Node since version 0.1. I come to the specialties later on. So we have this magical get right. Can you ask another question so that I can drink something? So, okay, so we have this magical writable stream coming from somewhere, and now we have two functions on this. And this is basically all you need to know about writable streams. And the first function you can call on a writable stream is, what a surprise, write. Well, writable stream, write function, it's quite obvious. So we can say, let's write something. And the big question is now, what are we able to write? And basically we have two options. The first thing is we can write a string, and we can write a buffer. A buffer is basically an array which contains binary data. And you can create buffers in Node very easily by calling the new buffer constructor. And well, a buffer is basically nothing. How do you fill data into a buffer? There are lots of options, including fancy things like handling unsigned ints with 4 bytes or something like that. But the most easy way to create a buffer is by providing a string. So, and now there's one little caveat you need to know about. And this is, as I said, buffer is binary. A string isn't binary, a string is text. And there's one little difference between binary data and text data. And this is, binary is just raw bytes. This means this string up there is probably 10 bytes. Right?
Depends on the encoding.
Right, depends on the encoding. It's 10 bytes if we're talking about ASCII encoding. It's also 10 bytes if we are talking about UTF-8. It's not 10 bytes if we are talking about UTF-32, for example. So the binary data is just a number of bytes, but the string is an interpretation of these bytes. So in the end, what we need to do to convert a string to a buffer is we need to tell the buffer constructor which encoding we would like to use so that it creates the correct binary data. So, for example, we might say, well, we want this to be UTF-8. Most of the times when you deal with text data, it's probably UTF-8. So Node has the convenience to say, well, if you don't specify an encoding, I guess it's UTF-8, so everything's fine as well. And what you can also do is you can skip this buffer thing and provide the text directly to the write method. And again, the same rules apply. So Node guesses this is UTF-8. If not, you have to specify what it should be. So this is method number 1. Method number 2 is you can call write over and over and over and over again. Always write to that stream. Since it's a stream, like a river, you pour water in it and pour water in it, and again you can pour water in it. And at some point in time you are done. And this is when you want to close that writable stream. And this is when you say writable stream.end. And the end function optionally takes also a text. And if this sounds familiar, because everybody starts writing HTTP servers and writes to the response object and then ends the response object. The response object is just a writable stream. And this is why response has a write and an end method. So basically, this is what you need to know about writable streams. On the other hand, we've got readable streams. And readable streams are unfortunately much more complicated. In the beginning, it was oh so easy. So we could say, well, let's get a readable stream from somewhere. And we then have a variable readable stream. So now we want to get data. And we don't know how many data are available because it's a stream. It's an array filled over time. So we need to get an event which tells us, hey, I've got data for you. And until Node 0.10, there was only one version how you could do this. And this version was readable stream on, and you subscribe to the data event. You had a handler for this, which got the data, and then you could handle that data. And again, this data basically is a buffer. So usually I fall into the trap of thinking, hey, it's a stream, and use it like a stream, and then wonder why it doesn't work, because it's a buffer, and you have to call toString on it. Again, providing an encoding. Or what you can also do, you can call a readable stream dot set encoding function, and example given, say, well, the data I expect is UTF-8, and then you get UTF-8 as strings. So, and there's one very, very, very important difference between getting a buffer and calling toString with UTF-8 on it, and saying, well, stream, you are UTF-8, give me strings directly. And this is, again, a thing which in 99.9% of the times won't happen to you. The difference is when we are talking about encoding such as UTF-8. Some characters are encoded as 1 byte. And as long as we do this, everything's fine. It doesn't make a difference if you use set encoding and get a string, or if you don't use set encoding and get a buffer and convert it. The difference happens when you have UTF-8 characters with more than 1 byte. The problem then is, let's suppose you have a German umlaut, like ä, ö, ü, or something like that. They are encoded as 2 bytes. And if you don't use the set encoding function, it may happen that the data parameter only includes the first byte of your 2-byte character. Well, you don't know that. So you call toString with UTF-8 on the buffer and get the wrong string. If you use the set encoding function instead, Node is intelligent enough to handle this for you. So this is the way more better approach. Of course, I have to say, of course you could detect this by yourself by looking at the single bytes. And of course there's a system behind UTF-8, so it's no magic that Node does this. But you don't have to do it manually, and most of the times, if you had to do it manually, you will forget about that. So this is the approach you used until Node 0.8 including, and if you were interested in when the read stream ends, example given, the file is being read to the end, then you could also listen for an end event, and again you have a callback and can handle this event gracefully. So this is what streams look like in Node 0.8. Now there's a little problem. Now we get to the pipe function. Suppose we want to pipe this stream, this readable stream, to that writable stream up there. What we basically need to do is nothing but listen to the data event and then say, whenever we get a data block, write it to the write stream. And when we get the end event on the readable stream, and the writable stream as well. It looks so easy. Now the problem is, again, most of the time, this will work. The problem appears when the two streams have different speeds. If the read stream is able to read way faster than the write stream is able to write. Because this means the read stream is, hey, I've got data, I've got data, I've got data, I've got data, I've got data. And the write stream says, okay, you have some data for me to write. Hey, not so fast, please. Let me write that data first, and so on. And you can guess what happens. You overflow the writable stream, and the writable stream, of course, has an internal buffer which fills up, but this internal buffer is not 3 gigabytes in size. And in the end, if you wrote in the same speed as you're reading out, you could say, well, it's basically the same as our very first example. So what we need to do is we need to detect, is the write stream coming up? Is it at the same speed as we are reading? So what you can do is this write function returns a boolean which tells you so. So was able to write yes or no. And if so, everything is fine. Then continue. But if it was not able to write, you should pause the readable stream for a moment. So we can say if not was able to write, oops, that's not a function. If not was able to write, we need to pause the readable stream. And now, of course, everything will stall because somebody has to resume the readable stream at the right point in time. And for that, again, the writable stream again has an event which is called drain. And this basically means, okay, I'm now ready and you can give me more data. So when we get the drain event from the writable stream, we can call readable stream resume and everything's fine again. So that's in theory. What we are now missing is error handling, example given, and well, different buffer sizes and things like that. And you don't want to deal with that manually. So to cut a long story short, this is basically what happens internally when you call pipe, but just use pipe. It's easier. And it's more fail-safe. And then there's another problem. No, there are other two problems. First of all, pause and resume, at least in Node 0.8. Don't do what they suggest they should do. So what do we expect? What happens when we call pause on a readable stream? We think that it will stop emitting data events. What actually happens is that the readable stream, well, if it likes to, it stops sending and emitting data events. If not, it will continue to do so. And then we've got a problem. So pause and resume as well, they don't say do it. It's more like it may be nice if you could do, if you want to, and you like me, and you've got a good day, and so on. So this is not such a great implementation. And the last problem with this is that there is a timing problem, because the readable streams, once you've got that readable stream, will start emitting data events. So here, it's not a problem, because once we have the readable stream, we set its encoding, and then in the same tick of the event loop, we say, well, of course, when you get a data event, react on it. So no data events can be lost, as there's no turn in the event loop which comes in between. But if you now, well, let's say you get that readable stream, and only when it is opened, you need to do something else asynchronously to get your writable stream, then you may lose data events. And this was hard to deal with in Node 0.8. Fortunately, Node 0.10 got way better. And basically, you can forget about all of this. And the readable stream is now a readable stream version 2. What this means is the readable stream won't start emitting data events. It starts in a paused state, and it won't emit anything as long as you don't tell it to emit data. And there are two ways. And now it gets a little bit complicated. And there are two ways in Node 0.10 of how to deal with this. Basically, streams or readable streams may be in a flowing mode and in a non-flowing mode. Flowing mode basically works very similar to what you know from Node 0.8. So when you do nothing special, you've got a stream in flowing mode. This stream is paused, and it waits for you to attach a data event handler. So basically, it looks the same, but it doesn't do the same. If you don't attach a data event, the stream will be paused. And this means if you also have a listener for the end event of the readable stream in Node 0.10, of course, the end event can only be emitted when the stream is at its end. But for the stream to get to its end, this means that the stream must be replayed. And this means that it may not be paused. So there are situations where you're not interested in the data, you only are interested in the end. For example, you send an HTTP request somewhere and you are only interested in the status code that is returned. So you get the response stream, you throw away all the data that is in the response stream and wait till the end, because then you have the status code available. And in Node 0.8, this worked. Just don't listen to the data event, then all the data is lost. And once the end event happens, everything is fine. In Node 0.10, this won't work anymore, because the stream starts in a paused state. And to make it flowing, as I said before, you can either attach a data event, then everything is fine. Or if you say, well, I'm actually not interested in the data, then you need to call the resume function, which now in Node 0.10 actually does what its name says. Now it resumes that stream. And again, there's a pause function, which now also does what its name suggests. So pause and resume now work the way you would expect them to. So this is how flowing streams work in Node 0.10. But there's another interface how you can interact with streams, and that's a little bit more, it's a little bit more convenient. And that idea is that you don't use the data event, but there's a completely new API. You can say, well, we have a readable stream, and we are going to listen for the readable state, which means basically, well, now we have some data which are ready to be read. And you can handle that event, or you can not handle that event, doesn't matter. As long as you don't actively read that data out of the stream, the data stay in there. And you see that this is a little bit different, because the readable function event handler does not take a data parameter. When we had the data event, the callback automatically got the data. The readable event handler is only a notification, hey, there are data ready to be read. As long as you don't actively read them, they stay in the stream. And to read them, you have to say, well, var data is equal to readable stream dot, well, analogously to the write function, we have now a read function. And this now returns the data in the stream. And if you don't call this for whatever reason, it's perfectly safe, and you will get the readable event at some point later in time again and can read the data then. What's important is that once you have used on readable, the stream switches to the non-flowing mode, and this means you are no longer able to use the data events. Once you have switched to non-flowing mode using readable, this means that you cannot go back. So using readable means switch from flowing to non-flowing mode, but there's no way back. You cannot switch a stream which is in non-flowing mode back to flowing mode to then again use data events. And now the question is when to use what? And basically the advice is when you want to have a convenient API, use the readable API. But it's a little bit slower. If you need ultra high performance readable streams, stay and stick with the classic data event. But the important thing is that you then have to remember that the stream starts in paused state, and you either have to subscribe to the data event, or you have to call resume. So that's it on readable streams. And that's the usage of readable and writable streams, and a little bit about the problems that may appear with 0.10. So now, this is just you. Yeah, that's a question.
So that you can drink a little.
Thanks a lot.
How do you set the buffer size for this reading or writing streams?
There's you don't do it here at all. Basically, when you create a stream is basically a class, and when you instantiate this readable stream or writable stream class, you can provide an options object. In this options object, there's a property called high watermark, and this is basically the size of the buffer that is used internally. By default, I'm not too sure, it's either 16 or 64 kilobytes. One of those two, I need to look it up.
And also for timeouts and end of streams, how do you can configure that as instantiation time?
Timeouts are not supported out of the box for a stream as is. You need to do that on a stream implementation. But we come to stream implementations in a second. Yep.
Could you explain what's the convenient part about that?
Well, the convenient part is that you may decide, for example, well, I only am interested not every time the readable event happens for performance reasons, because we don't want to, write each time a readable event occurs only every 10th time and then all the data at once. So you can have a counter and, for example, say on readable, if I equal to 0 or to 1 or to 2 and so on, simply return, and you don't have to save the received data somewhere internally, because the data is still in the stream. If you're using the data event, you need to have a variable which buffers the data for you, as the event handler already gets the data, and you can't say, I don't want to have that data right now. And with Readable, you can say, well, I'm not interested now, just give it again to me at a later point in time.
Isn't there like an option to define the minimum data amount?
Not from the usage part. It may be possible on the implementer size, on the implementer's part, but not from the using, at least as far as I know.
Because that would solve the same.
Yeah. So now we've talked about using streams. Now let's look at the more interesting thing, how to implement streams. And this time, fortunately, the readable stream is a little bit easier to use than the usage side. What you basically need to do is you need to require the stream in the util module, and then the stream module provides a class or a constructor, that's the better word for it, called Readable. And you basically need to create your own custom constructor, MyStream, and make it derived from stream.readable. And this is the point where you can hand over the options object, and where you can set things like high watermark for setting the buffer size or things like that. And then all you have to do is call util inherits MyStream readable. So, and the interesting thing is that then on a readable stream, we have a function of this on the stream's prototype called _read. And this is a function which has a size parameter. The user of the stream can request a specific size by calling the read function. You can hand over a number of bytes you would like to have at a minimum. What you would like to have, but this is only an optional argument, and the _read function is completely free to ignore this value. It's up to the implementer whether he's interested in that or not. And in there, you can do whatever you would like to do to get some data. And what you then can do if you have some data is call a function on this. This points to the stream itself, of course. And this function is called push. And basically, the data you would like to emit using the readable stream to all the subscribers of the readable stream, you need to push. So for example, we could create a stream that pushes a 23 and does this in a loop or whatever. And once you are done, you push null. And this is a magic value when you implement a readable stream. So it's not possible to create a readable stream that emits null as data. Use undefined or an empty object or anything, but at that moment where you emit null, you are emitting the streams, the readable streams end event. This is really important to remember. Yeah.
Isn't this approach also presenting the same problem with multi-byte characters, like you mentioned before?
Node will handle this internally when you call the set encoding on the stream. But this is again on the user's side, not on the implementer side.
So if you push 23 bytes, assuming the last byte is part of 2 bytes,
then Node on the user side will handle this for you, and you're fine. This the base class does this for you. So now to have an example of what this may look like, I've got a ready-made example, a stream which creates prime numbers. It's also a stream basically, just a generator for numbers in a minute. And basically, well, we have the stream and utils and the readable, then a little small function, just a helper function to decide if a given number n is a prime number. And then we have the stream primes, which has, besides the options object, which has a max number. So we only want to generate prime numbers up to a given number. And well, we remember this maximum, and that's set the start index to 2, as this is the smallest prime number that exists. And then inside the read function, we simply have a do while loop, and while we did not find a prime number, and check the index, is it a prime? If so, say, yeah, well, we have found one, and push it out to the user. And this runs until the index is greater than max, and then we push null, and then the stream ends. So we have, at a very easy, with a very easy model, have a stream for prime numbers. And if we would like to use this stream, we could do something like this. For example, say var primes stream is equal to new primes, and well, options are optionally, and let's say max is 100, and then on the primes stream, let's say we listen to the data event, and whenever we get some data, we simply print it to the console. So console log data. I'm skipping all the things about encoding for the moment, and then we say primes stream on, and well, we don't need that actually. So, and once we have that and we run this, okay, now I need a terminal. Let's make this a little bit smaller. So once we have this, let's go to the MNUG folder and run readable primes, and you see that we now get all the prime numbers from 2 to 97, which is the greatest prime number below 100. And if we now say, well, let's take all the prime numbers up to 1 million, you see that it calculates, and well, it's quite fast. But this is now prime numbers implemented as a stream, not as a simple boring for loop. And the interesting thing is, once you start thinking about readable streams, not only it's a network resource or file resource, but every data source can be modeled as a stream. Of course, it's not useful to use it for anything. Streams are not the silver bullet, but the nice thing about streams is that they can be piped, as we have seen. So this means if you have some data transformation in multiple steps, then you can easily start with a readable stream with an own implementation and pipe it to another stream that transforms this data and again transforms the data and so on. And you can have a multi-step stream transformation algorithm modeled very easily. So, but when I say we can pipe a readable stream to a writable stream, we also need a writable stream, potentially a custom writable stream. And the nice thing is, once you are used to this model, let's switch back to it, of how to implement a readable stream using or creating a writable stream, looks nearly the very same. The only difference is that you need to derive from stream.writable and that you don't have an underscore read function, but an underscore write function. That's the only difference in the end. So let's look at the template again. And the reason why I've got those templates is just to not have to type all these things again and again and again. Basically, it's quite easy. All the things in the first 11 lines are the very same as with readable streams, just writable instead of readable. Now, the prototype has an underscore write function, and here you get the chunk which shall be written, you get the encoding, and this is important, you have a callback, and once you are done with that chunk, you need to call that callback to notify Node, well, I'm done, and you can call underscore write again to write the next chunk. And an implementation of this may look like this. This could be a simple logger. And, well, we could say we have a message, and the message has an index. The index is just an internal variable of the logger stream. You start by 0, and on every log message, you increase it by 1. You get the timestamp, and you simply say, well, the incoming chunk, transform it to a string with UTF-8. Let's suppose it's UTF-8, and write it to the console. And if you want to use that logger, it's as simple like saying var logger is equal to new logger stream, and then logger write hello and logger write MNUG, and that's it. And this is number 8. When we run this, you see that we get a very nice exception because. Oh, yeah. Thanks. So, and then you see that we get 2 log messages with an increasing index with a timestamp and the message we just sent. So, using a write stream or implementing a write stream is that easy. There's only one little disadvantage, or, well, it's not a real disadvantage. It's not as comfortable as it could be. Because at the moment, because the chunk is a buffer or a string, we are only able to log string messages. What if we, example given, would like to log some additional metadata, a JSON object, or if we would like to specify a log level or something like that. So what we would like to do is call logger.write, but not specify a string, but specify an object with a log level, with a message, with some metadata, and so on. And there is one very interesting idea in Node streams. And this idea is that streams are usually in the buffer/string mode, but you can switch to a so-called object mode. And if you activate this object mode, forget the encoding, then we're talking not about buffers and strings anymore, then we're talking about objects. And activating object mode is really complicated. One line. And all you have to do on the options object is add an object mode property and set it to true. And then the rest looks exactly the same. You again have the underscore write function with chunk encoding callback. The encoding is entirely, you can skip it completely because it's not of interest anymore, as chunk now is an object. And as you can see here, we are again constructing a message and putting it to the console, and the message has the index, the timestamp, but now we've got a level, a message, and metadata, and we get these as properties out of the chunk. So if we want to use this object logger now, we can say var logger is equal to new logger, and then logger.write, and now specify an object, and let's say, well, this is an info message, and my message is hello MNUG, and logger.write, well, level is worn, and message to myself is only 10 minutes left. So if we now run this, you see that we get 2 nicely formatted JSON outputs to the console with the different log levels and so on. And of course, now we can hand over anything to the stream. The only thing that we have to watch out for is that we only have one parameter, as we have only got one chunk parameter. So if you now want to say, well, I've got a message as a string and metadata as a second parameter, you need to use a custom wrapper around underscore write. So this is basically what you need to know about writable streams, how to implement them. And now comes the really interesting part, because now the next thing is write streams that are readable and writable at the same time. And those streams are called duplex streams. And well, good question is, what do you derive from? Because with the writable stream in line 10, we are calling the writable constructor. In the readable stream, we call the readable constructor. Now we need to call the readable and the writable constructor, but obviously that's not the best idea. And one object in JavaScript cannot have two prototypes. And nice for us. Node already solved this for us, because Node provides a duplex constructor, which is basically the readable constructor, which copies the writable things in. So the template for a duplex stream is again the very same. You have stream.duplex, call the duplex constructor, inherit from duplex, and now, of course, as it's a duplex stream, you have to implement a read and a write function. That's it. And all you need to know about implementing readable and writable streams is valid here as well. There is one thing to note. A duplex stream just means it's a readable and a writable stream. It does not mean that the readable part and the writable part do have anything in common. It could be a stream that reads from a database but writes to a file. Basically, or a prime number generator, which you can also use as a logger. Would make up an interesting constructor name, I guess. But most of the times, you will have a duplex stream, which is written to, which does something to the chunk and emits it using a data event. So basically a duplex stream that transforms the data that flows through it. Whoa, that's meta-philosophical. And for this, Node again has a special constructor. It's a so-called transform stream. And that's the upper class of streams where you can get to transform streams. Basically, how you create one, it's the same as every time. And now we've got a transform function. And basically, this transform function is a read and a write function at once. So it has the signature of the write function, so you get a chunk and an encoding, or if you put that to object mode, you get an object and you can ignore the encoding, and you have the callback. But you also have the option to push that data again to the outside. So transform data might be something as easy as transforming a lowercase string to an uppercase string. Something stupid as a to lowercase or to uppercase function can be implemented as a transform stream. And this looks like this. That's a very easy transform stream called to uppercase. So we take the chunk, say, well, let's transform the buffer chunk to a string in UTF-8 and transform it to uppercase and push it out again as UTF-8 and then call the callback to sign or to notice Node that we're now done with that chunk. To be true, it's a quite complicated version of toUpperString, but it works perfectly. And to show that, we can say var toUpperStream is equal to new toUpperCase. And then whenever you have some uppercase data for me, print it to the console. And now let's say write some data in lowercase. For example, it is always nice to be at MNUG. So, And if we run this, this is number 12, then you see that we get a buffer. Of course, because we push a string, but this we didn't set encoding. So we have to call toString UTF-8 here. And if we do this now, we have an uppercase string, which tells us that it's always nice to be in Munich. So, and this is basically how transform stream works. And this is a transform stream that takes the input data, transforms it, and writes it out as output data. And this can be run at the same time, so data can flow through that stream. There's only one problem. This does not work with all data. Perhaps if we would like to write a stream that reverses its input, we first need to capture all the input and then write it out in reversed order, because for writing the reversed first package, we need the input last package. And this is hard to do with a single transform function. And this is where another function, which is called flush, comes into play. And this is basically called when we are calling the end function on the writable part of the transform stream. So what this does is, whenever a chunk is coming in by calling write, we get the text and we split it, so we get an array, we can reverse that array, put it again together as a string, and add it to the so far reversed text, and store it in an internal variable, and say, yes, we're done, we're not calling push at this moment. And at the moment when the write stream ends, flush is called, and this is the point in time where we push the entire reversed string out. So this is more like, here's the transform stream and data is not flowing through it any longer, but data is going to it, it's getting more and more and more, it's collected and transformed, and when you're done, then everything is released all at once. And this looks like this. Let's say we have a reverse stream, it's a new reverse stream, and say reverse stream write hello reverse stream write MNUG reverse stream dot end, and on the reverse stream we say whenever you get some data, console log, oops, I forgot the data parameter, console log that data, it's an UTF-8 string. So, and if we run this, you see that we now get hello MNUG in reversed order. So this shows that this works even with multiple write calls. So, and now the interesting, yeah?
But you still have the problem of hitting the high water mark.
No, because this now here is our very own internal own variable, and there's no connection between this property, which is defined up there, to the high water mark. We don't look out for the high water mark here
Okay,
anyway.
sorry. Yeah.
No problem. And now the nice thing is, if we copy together the reverse string and the toUpper string into one file, we require both, we can now pipe them. So we could now say, well, let's create a reverse stream and then a toUpper stream, pipe them, and then write to the reverse stream and listen on the toUpper stream, and then we get a reversed uppercase text out of it. And this is the real power of streams. And one final real life example, my last minute is running, is a getLength stream. And the idea of the getLength stream is we aren't interested in transforming the actual data. We just want to spy on it. Let's call this NSA stream or something like that. And what we're basically doing in our transform function is just we have a length property, which is initialized to 0. In our transform function, when a chunk comes in, we just take the chunk's length, add it to this internal variable length, and push out the chunk again. So basically, this transform stream is invisible. It can be injected in between two streams without changing anything. It does its work silently. And at the moment the write stream ends, flush is run, and then we emit a length event and emit the length. And this basically, in the most easy case, looks like this. we say, well, get length stream is equal to new get length, and then we say get length stream. When you have the length information, you get it here, then console.log it. And then we are starting to writing data to the get length stream, such as hello and MNUG one more time. And finally, we say get length stream dot end. And if we run this, you see that our stream emits a length event, which a string length of 10, which is correct. If we add hello, space, and MNUG, that's 10 bytes. So we have an invisible stream that can emit additional data. And this, of course, to get the length of a string, nobody would use a transform stream. But this is interesting, for example, if you would like to get some statistics on incoming or outgoing traffic. Simply write a stream which measures the chunks that are flowing through it, add it up, get some statistics like how many bytes above 127 are there, or how many bytes per second come in, and from time to time emit events. And this way you can very elegantly get statistical data about your about what's going on in your application. And the really nice thing is, and this is the big well, shortcut to the beginning, and all this you can do on the fly. So you don't have to wait for anything. You don't have to use lots of memory for this. It all happens with flowing, with very little system performance. And this is why Node is great, because it allows us to do highly scalable systems which build upon things like that. And this is why streams is such a great concept. And it's someone, I guess it was Dominic Tarr, but I'm not sure about this, once said streams are the most underused concept and misunderstood concept in Node.js. And once you start working with streams and you have written a Vue transform streams to get a feeling for that, you start to think differently about data transformation and about the way you write your applications. And I can only suggest to anybody, do it and work with it. It's a lot of fun, and it will change the way you write your Node applications. And final sentence, when you then have a great enterprise level statistics gathering transform stream, submit it for Enter.js. Thanks. So are there any questions? Yeah.
Before, when you talked about readable streams, you said subscribers, plural.
Yeah.
Could there be more than one subscriber for a stream?
Yep.
For the same readable stream at the same time?
It depends. In Node 0.10, yes, you can just have multiple subscribers listening to the onData. It only works with data event. You can then listen to the onData event with several subscribers, and that works perfectly.
They get all the same data?
They get all the same data. In Node 0.8 and below, it does not work. There you need a special multiplexer transform stream. There are ready-made modules for this in NPM, but it does not work out of the box. And one thing you can do with this multiplexing, for example, is we wrote a logger for us, which is basically based on a transform stream where we have multiple write streams listening as a target for the console, for a file, for the database on, and we just log to a transform stream. And the multiplexing and the streaming does all the rest. Any other questions?
But if they're issuing like pause and so on, they will of course interfere.
Yes and no. Again, it depends on the Node version. Below 0.10, yes, there are problems. In 0.10, Node synchronizes all the streams and and synchronizes with respect to the slowest stream. So it should work the way you expect it.
Mm-hmm.
Of course, if you, especially with the logger, if you log too much information, there's a problem, of course. Yeah. Okay, time for one, yeah, okay, or for two last questions.
was just wondering if you use your first example, the 3 gigabyte file, you push it into the reverse string function. Will it work?
Well, depends on the memory of your MacBook. On my one, it could work, perhaps. I don't know. I have never tried to put 3 gigabytes in memory with a Node application. No idea. But in case anybody of you is coming from a .NET background, is anybody? Oh, okay, one person. And there's the magazine .NET Pro, and in .NET Pro February 2014, there's a new series starting where another author and I are battling each other, Node versus .NET, and this is our very first task, write a web server that delivers large files. I have, of course, used streams. I'm curious what the other guy did. And yeah, then perhaps we will try it out with 3 gigabytes. But there was another question.
But
Yeah,
stop, sorry.
Just a last addition. If you search online for Node Streams Playground, there is a nice website by John Racing where you can play around with a lot of streams typed in together, and it's a nice playground.
Yeah, very good advice. Thanks.
Send it out through Twitter. So, thank you, Golo, for another great MNUG talk. Thank you.
You're welcome.